Section 5. Putting it all together. In this section, we describe the building blocks of Aurora as shown with a bird's eye view in Figure 5. Figure 5 shows S3 at the bottom in a red rectangle, a cloud labelled Storage VPC, a cloud labelled RDS VPC, and a cloud at the top labelled the Customer VPC. The customer application is in a rectangle within the Customer VPC. The RDS VPC contains or has links to a primary read-write database and a secondary read-only database. The database engine is a fork of community MySQL/InnoDB, and it diverges primarily in how InnoDB reads and writes data to disk. In community InnoDB, a write operation results in data being modified in buffer pages and the associated redo log records written to buffers of the write-ahead log in LSN order. On transaction commit, the write-ahead log protocol requires only that the redo log records of the transaction are durably written to disk. The actual modified buffer pages are also written to disk eventually through a double write technique to avoid partial page writes. These page writes take place in the background, or during eviction from the cache, or while taking a checkpoint. In addition to the I/O subsystem, InnoDB also includes the transaction subsystem, the lock manager, a B-tree implementation, and the associated notion of a mini-transaction, or MTR. An MTR is a construct only used inside InnoDB and models groups of operations that must be executed atomically, e.g. a split or merge of a B-tree page. In the Aurora InnoDB variant, the redo log records, representing the changes that must be executed atomically in each mini-transaction, are organised into batches, and they're sharded by the protection groups each log record belongs to. And these batches are written to the storage service. The final log record of each mini-transaction is tagged as a consistency point. Aurora supports exactly the same isolation levels that are supported by Community MySQL in the writer, the standard ANSI levels, and snapshot isolation, or consistent reads. Aurora read replicas get continuous information on transaction starts and commits in the writer, and use this information to support snapshot isolation for local transactions that are of course read-only. Note that concurrency control is implemented entirely in the database engine, without impacting the storage service. The storage service presents a unified view of the underlying data that is logically identical to what you'd get by writing the data to local storage in Community InnoDB. Aurora leverages Amazon Relational Database Service for its control plane. RDS includes an agent on the database instance called the host manager that monitors a cluster's health and determines if it needs to fail over or if an instance needs to be replaced. Each database instance is part of a cluster that consists of a single writer and 0 or more read replicas. The instances of a cluster are in a single geographical region, e.g. US East 1. They're typically placed in different AZs, and they connect to a storage fleet in the same region. For security, we isolate the communication between the database, applications, and storage. In practice, each database instance can communicate on three Amazon VPC networks: the Customer VPC, through which customer applications interact with the engine, the RDS VPC, through which the database engine and control plane interact with each other, and the storage VPC, through which the database interacts with storage services. The storage service is deployed on a cluster of EC2 VMs that are provisioned across at least 3 availability zones in each region, and is collectively responsible for provisioning multiple customer storage volumes, reading and writing data to and from those volumes, and backing up and restoring data to and from those volumes. The storage nodes manipulate local SSDs and interact with database engine instances, and with other peer storage nodes, and the backup and restore services that continuously back up changed data to S3 and restore data from S3 as needed. The storage control plane uses the Amazon DynamoDB database service for persistent storage of cluster and storage volume configuration, volume metadata, and a detailed description of data backed up to S3. For orchestrating long-running operations, e.g. a database volume restore operation, or a repair operation, re-replication, following a storage node failure, the storage control plane uses the Amazon Simple Workflow service. Maintaining a high level of availability requires proactive, automated, and early detection of real and potential problems before end users are impacted. All critical aspects of storage operations are constantly monitored using metric collection services that raise alarms if key performance or availability metrics indicate a cause for concern. And that's the end of section 5, putting it all together.